Okay, can we start?
Yes, sir.
Good evening, everyone. My name is Vinayak Elangovan. I'm an assistant professor of computer science in information science and technology department. And currently, I'm in Penn State University, which is in Pennsylvania. So today, I just want to give you an overview of one of my big research project I carried out for almost 8-10 years. That's about group activity detection and recognition. So I want to give an overview. What is the group activity and what are we trying to detect and recognize? And how do we recognize and how do we summarize those activities? So that's what our target for our today's presentation. Okay. So before we do that, I want to give an overview why security is very important. If you see, security is almost important in all the domains. Doesn't matter if it's a battlefield application or a homeland security or manufacturing industry or in schools, colleges, everywhere, security is always very important. So one incident which motivated us to do a lot for this particular area is, you see this image under civilian safety. So this incident happened in 2011. It's a Times Square bomb incident. So this person you see under the circle, so this person, he got out of an SUV and he was carrying a backpack. He dropped the backpack under a lamppost and he quickly changed his shirt and he left the bag there unattended and he left the scene. So somebody was watching this scene and they found it very suspicious. So they called the authorities and the authorities immediately came and they found that there were some bomb materials, some wires and some very suspicious materials inside the bag. And somehow they traced his SUV and somehow they traced his apartment and they went to his apartment and found that there were more bomb materials. Okay. So now the question is, what if the person who reported to the authority, if that person didn't take any time to report it, what would have happened? Something really bad would have happened on that day. So in case if we have a camera which can capture all the video, and if the system can identify what is a normal behavior and an abnormal behavior, and if it can send that information to the authorities to make a decision, that would be fantastic. Okay, so soon after this incident happened, I think very next week, people were very panicked. So they were overcautious. And there was some unattended cardboard box lying on the road. And someone found it suspicious, and then they called the 911, and the authorities immediately came, and they found that that cardboard box had only pack of Coke cans. Okay, it's just empty Coke cans. And they brought all the bomb squad and the K9 dogs and everything. So this is actually a waste of time. Okay, this creates an unnecessary panic among people. So a system which can identify all this behavior and give the authorities to make a decision would be an ideal one. Okay, so that is our area of focus. So what we are trying to do here is, if we have a video, can we identify the behavior activities in that video and try to summarize what is happening in that video so the authorities can make a decision. Okay, so our goal is not to say that it is a suspicious activity or it is not a suspicious activity. Our goal over here is to classify whether it is a normal behavior or an abnormal behavior. Okay, So typically when we talk about the group activities, what do we mean by group activity? The group activity typically involves multiple entities, like multiple people involving in a particular action. And when these people involve, especially in the outdoor activities, there might be some vehicle involved in the scene. There might some objects involved in the scene. Group of people are getting out of the vehicle or exchanging some objects or even exchanging the vehicle. All these are considered for us as a group dynamics. So we are very interested in identifying these kind of activities involving people, involving vehicle, and involving objects. Okay? So, so this process of understanding this group activity is typically involved with space and time analysis. Okay? And to understand this behavior, only one camera is not sufficient. So we need multiple modality sensors, meaning we can have a camera, we can have an acoustic sensor, we can have an infrared sensor. Multiple sensors can be deployed in that area to identify the behavior. Okay? But even if you have multiple sensors deployed, video imagery is one of a very popular sensing modality, which can give us very good data to analyze. Okay? But even though you have all these data coming from this video images, understanding each image, understanding the behavior from each image, and making sense out of it is a very real challenge. Okay. So in order to do that, what we do here is we try to identify the events in each images, and each events, a sequence of events, is going to contribute to a particular action, and a sequence of action is going to contribute to a particular group activity. Okay, so what do we mean by action? For example, if I move my hand, that could be an event. Okay, so any movement I make, that could be an event. But if I move my hand to take a coffee cup, that could be an action. So sequence of events is going to make an action. Okay, and sequence of action is going to contribute towards an activity. And in that activity, if we have multiple entities involved, we call it as a group activity. Okay. So in order to identify these group activities, we can categorize the group dynamics into three different types. We are interested in identifying the human-human interaction, how a human can interact with other humans. For example, shaking the hands, hugging, or waving the hands, and so on. Okay, why do we need to do this human-human interactions? So we want to identify the relation between the people. For example, if a person is saying hi, and then probably these two people are connected. Okay, and if a person is hugging another person, probably they have met before, so they know each other. Okay, or probably they have some close relationship. So we want to identify this kind of relationship by identifying this human-human interaction. And human-object interaction, we are interested in how the person is carrying the object, or dropping the object, or placing the object inside a vehicle, or inside a warehouse, or whatever it is. Okay? And finally, the human-vehicle interaction, which will be one of our focus in today's presentation. In human-vehicle interaction, we are interested how a person is manipulating the vehicle. For example, opening the door, closing the door, opening the trunk, closing the trunk, changing the tires, or manipulating in any part of the car or any part of the vehicle. So that would be considered as human-vehicle interaction. Okay. Okay. So before we go to our outline presentation, I want to show you a small video. Okay. So this a particular video is being captured in a warehouse. Okay, so if you see, there is a vehicle arriving in the warehouse and a group of people are exiting from the vehicle, and there was a person standing in the warehouse, and that person is waving towards this group, and they started unloading the objects and placing that in the warehouse. Okay, so if you look at this video, what we are interested here is we are interested in how many vehicles are involved. Okay, how many vehicles are involved, how many people are involved, can we able to track the people, can we able to identify who is performing which action, can we identify how many objects are being carried from the vehicle to the warehouse and so on. Okay, and let's watch this one more time. So if you carefully look at this particular person is waving the his hand to this person. And if you watch the entire video, this person is not doing any activity at all. So he is just monitoring the activities and he is guiding them what to do. Okay. So our goal is to identify that kind of activities. So we want to identify who is performing the activity, who is not performing the activity. So if we analyze this video, we can come to a conclusion that this person might be the leader of this group because he is not doing any activity, because he is just guiding others to do the activity. Okay, so we want to tag who is the subordinate, who is the leader in the group. Okay, so that kind of behavior also we are very interested in identifying. Okay. All right, so before we talk about the activity recognition, I just want to give you an overview of the entire system. I want to give you an overview of what is computer vision and what is machine learning, and then we can talk more about the scene analysis. Okay. So in any computer vision related applications, we have three different kinds of process. We have low level process, we have mid level process, and we have higher level process. Okay. So basically in low level process, what we do is once we get the images, we want to clean up the image in the sense, if there is any noise, we want to remove the noise. And if the clarity is not good, we want to sharpen the image, and we want to clean up those images, clean up those noises, filter the foreground from the background. All those processes would be considered as low-level process. Okay, and in the mid-level process, what we do is we try to identify the information from the images. Okay, so what we can observe from the images, identifying those events, performing some event analysis, and identifying the observations, the actions from the images. That we will call it as mid-level process. In higher level processes, okay, I found some observation from each image. Now, what can I do? How can I make sense out of it? So that involves higher level process. For example, a simple scene, let's say a person is opening the trunk, is taking a big object, carrying a big object in two hands, and is coming to the rear wheel, is sitting over there, and is removing a big object, and then is placing the object he carried, is staying there for some time, and then he's carrying an object, placing that inside the trunk. Okay, so if we look at this, each image we can try to identify the events, and then we can try to identify the observations. Okay, what do we observe? What are the actions involved in this video? And what we can conclude that the person is probably changing a tire. Okay, probably he had a flat tire and he's trying to change the tire. Okay, so that is what we want to understand. So that's what the scene analysis means. Okay, so we want to, given a video, we want to summarize the video and we want to explain what is happening inside the video. Okay, so this application involves a numerous process of image processing. So I just want to give an overview. Okay, so let's say if I have two images, I can perform plenty of set operations, logical operations on two images. Okay, so we can combine two blobs together. When we say blob is nothing but binary large object. So you see this white thing over here. So that is the binary large object. Okay. So we can combine two binary large objects. We can detach two binary large objects, and so on. Let's say if I have two humans standing together, I can separate those two humans out of the single blob. Okay. And then I can perform analysis on each human. Okay. And plenty of morphological operations can be involved, like erosion, dilation, opening, closing, and so on. Okay. If two blobs are connected together, we can apply an erosion. Erosion is nothing but it is going to erode the binary large object so that I can separate these two blobs separately. Okay. And if I want to combine two blobs together, we can perform a dilation. Okay. And similarly, if we have any noise inside, we can do some filtering, we can do some opening and closing, and so on. Okay. And one of main important application in our field is the region detection. Okay, so our focus is to segment that entire image and try to find our region of interest. Okay, so to do this, we perform a plenty of different segmentation based on color. Okay, based on color or based on some features, we can perform plenty of different segmentation. So once we isolate our area of interest, then we can focus only on that area. Okay. Filtration is also very important in image processing. So given an image, if there are some noise, we can try to filter the noise, and then we can try to sharpen the images. We can apply plenty of different filters on an image according to our interest. Okay. So given two images, we can overlay those two images, we can combine the images, we can try to separate it. When we want to combine two images together, it is not that easy as it sounds. So we need to find common points between each image and find out whether these common points are the same and try to fuse those common points. Okay. Very good example is our Google images. Okay. So when we open the Google Maps and we see the satellite images over there, okay, there's not one single image. We have multiple images, and multiple images are stitched together based on the common points. Okay, so that is also very important to understand what features are there in the images and what are the common features between the images, so we can stitch together. Okay, so now let's talk about the conceptual overview of our system. So initially we have the image acquisition system, okay, meaning we have a camera which can capture the video, and once we get the video, we convert that video into sequence of images, okay, depending upon how much information we need. For example, if I need 3 images per second, I can do that. If I want more clarity, more information, I can do 30 images per second as well. Okay, so once we get those images, then now we can try to identify the targets in each image. Okay, so if you look at this, we are tracking each event here, and we are trying to track each of the target here. Okay, so once we detect the target, now our next step is to identify the target. Okay, so let's say I detect a target. Now I want to identify whether the target is a human or a vehicle or an object. And if it is a human, how many humans are there? How can we tag those humans? Okay, so in our case, in most of the surveillance video, the facial image is not going to be very clear. Okay, so if we don't have a very clear facial image, the only way we can tag that person is based on the shirt color or the pant color. Okay, of course, the question is, if everyone are wearing the same shirt color or a pant color, how do we tag them? So that is pretty challenging. Okay, so here we tag the person based on the shirt color and the pant color, and once we tag the person, we can track that person. Okay, so once we perform the target identification and tracking, Now we can try to identify what are all the events this person is performing. Okay, and then we can take all the sequential events and try to find what activity it is. Okay, so once we discover some activity is happening, then we can try to recognize those activities. Okay, so if you look at this, what we do here is we take each observation sequence, and then we try to predict the activity based on this observation sequence. How do we do that? We develop more ontologies. Okay, and once we have all those ontologies developed, we try to match our ontology with this sequence what we are getting. Okay, how do we match that? By using the statistical modeling techniques. So in our application, what we did is we developed hidden Markov models. So we used hidden Markov models to identify those sequence and to predict what activity based on those sequence. Okay, so once you recognize those activities, the next step is generating messages. So to generate these messages, we have a certain format, like an XML or HTML. All those formats are there, right? So we used a different format for generating those messages. Okay, so once we generate those messages, now the next thing is visual analytics. How well we can express these activities. Okay, can we summarize a 30 minutes video in 30 seconds? Can we make it as a short teaser or a trailer? Or can we just show as a strip of images? Or can we show as just like a 4 or 5 lines paragraph explaining those activities? Okay, so those visual analytics is going to show you all this different analytics, so we can easily understand what is going on. Okay, okay. I just want to give you an overview of this ontology development. Okay, so let's talk about only about this human vehicle interaction. So when we try to identify a human vehicle interaction, we consider all possible ways. Okay, what are all the possible ways we can come up with? We consider all those activities, and then we develop our ontologies. Okay, for example, if you're identifying the vehicle behavior activities, what are all the things are possible? Okay, so how the vehicle is being driven, and how the vehicle is, how the vehicle is parked, how the person is starting the vehicle, how we are manipulating the vehicle, how we are parking the vehicle. All those informations are very important. Okay, so we consider from two different points of view how this information can be extracted from images, how this information can be extracted from sound. Okay, let's say if I hear a screeching sound of a vehicle, then I can say that the vehicle had started pretty fast. Okay, so these are all the clues what we have. Okay, so let's talk about only this vehicle manipulation over here. So when we talk about this vehicle manipulation, different kinds of manipulations are possible. For example, how we open and close the door, how we manipulate in the exterior of the vehicle, and how do we manipulate inside the vehicle, and so on. Okay, exterior of the vehicle, what are the possible things? So I can do something on the body of the vehicle. I can go under the vehicle and do something. Okay, or I can work on the tires or the headlights or so. Okay, so many different ways we can manipulate the exterior of the vehicle. Okay, so once we identify what are all the different ways we can manipulate with the vehicle, then we can come up with ontologies. So when we come up with an ontology, we come up with one-man scenario and we come up with multiple-man scenario. Okay, so we have developed close to 250 ontologies. Okay, so once we have these ontologies, we can try to map those ontologies for a particular activity. Okay, for example, this is one simple ontology. If I find a person carrying an object, and if I find a person, the same person, opening the vehicle trunk. And if I find the same person placing the same object in the trunk, then I would say it is a loading object in vehicle. Okay. So if I observe these activities more than 2 times, then I would say it is a loading group activity. Okay. If there are multiple people involved. If not, I would just say it's a loading activity involved in that area. Okay. All right. So I just want to tell you that how complex this analysis can be. Okay. So to understand the group activities, we classify it into human-human interaction, human-vehicle interaction, and human-object interaction. Now I'm just talking only about the human-vehicle interaction. Okay. And in that human-vehicle interaction, if I want to tag that vehicle, these are all the important informations I need. I need to identify what is the type of the vehicle. I need to identify what is the color of the vehicle, and I need to identify the dynamics of the vehicle and which direction the vehicle is moving and what is the state of the vehicle. Okay, so when we talk about the state of the vehicle, is the vehicle is being parked, or is the vehicle is still moving, or is the vehicle is arriving or departing. All this will become the state of the vehicle. Okay. And human vehicle interaction, as we discussed, there are multiple different kinds of human vehicle interactions. All these 6 attributes are important in that human vehicle interactions. Okay, so if I want to describe the human vehicle interactions, I need the type of the vehicle, color of the vehicle, speed of the vehicle, moving direction of the vehicle, state of the vehicle, and what kind of interactions are being done with that vehicle. All those informations I need to generate a meaningful information. Okay. Okay. So why this vehicle orientation is very important. Okay. So for example, if you look at this, we have different orientations of these vehicles, right? I want to identify where the person is standing with respect to the vehicle. Okay. Let's say that if I identify a person getting from the front side of the vehicle, okay, if it is in US, if the person exiting from the front left side of the vehicle, we assume that that is the driver of the vehicle. Okay, if it is in India, if the person exiting from the front right side of the vehicle, we would assume that that is the driver of the vehicle. Okay, so that is the reason we want to identify the orientation of the vehicle, so we can identify who the person is. Is the person is the driver or the passenger? If he's a passenger, we are interested whether the passenger is exiting from the left side door or from the right side door. Okay. All right. Okay. So as I said, once we detect the target, now we need to identify the target. To identify the target, we used a simple neural network, okay, for object classification. Okay, so using the neural network, we classified whether it is a human or it is a vehicle, and we developed multiple neural networks to identify if it is a vehicle, what type of vehicle it is. Is that a sedan or a minivan or SUV or a pickup truck? Okay. Just for simplicity, we consider only these 4 different kinds of types of vehicle. Okay. So once we identify the type of the vehicle, now we want to detect the color of the vehicle and the orientation of the vehicle. Okay. All right. So this is one important thing we have addressed. For example, we are interested in the scale invariant features. Okay, so this is also very important. For example, let's say you have a pan tilt zoom camera or a very stationary camera observing a vehicle. Okay, image processing is very tedious. So if I get the image of the vehicle from a long distance, okay, the vehicle might appear very little. Okay? But if I go little closer, or if the vehicle arrives closer to the camera, you get a very good image. Okay. How do we differentiate that? Is that the same vehicle? Okay? So that is also very important. Okay, so you see the object, and when the object arrives closer to the camera, the features might change. You get a very enhanced features. Okay? How do we differentiate? Is that the same? Okay. And if the vehicle change its position a little bit, can we identify is that the same vehicle? Okay. So all these are very important. Okay. So what we did is we took the features of the vehicle and we developed an invariant scale feature. For example, if I have a smaller image size or if I have a larger image size, I find the same feature patterns. Okay. So we are interested in taking only those kind of feature pattern into account. Okay. So, and if I change the orientation of the vehicle, we have the same feature pattern. Okay, so only those kind of in-scale variant features we are considering, and then we use that for classification. Okay, okay, all right. So using the edge detection also, we can perform the classification. Okay, so we want to get the shape features of the object. Okay, so for example, if it is an SUV, the shape pattern is different. If it's a sedan, the shape pattern is different. If it's a pickup truck, the shape pattern is different. So we can take the shape pattern, okay, and use that shape pattern for classifying. Okay. So how do we detect the color? So we assume that most of the vehicle have one single pattern of colors. Okay? Let's say if somebody painted the car in different color, then it is going to be a little difficult. But if we have a unique same pattern, what we can do is we can try to take a region of interest. Okay? We can take multiple regions, identify the colors in multiple regions, and then fuse those together and come up with a common color. Okay, so that's how we recognize the color. Okay, so as I said before, vehicle orientation is very important. But how do we detect the vehicle orientation? One main feature pattern, what we understood is if we can detect the number of wheel. Okay, if we can detect the number of wheel and the shape of the vehicle from the top, we can try to identify the orientation of the vehicle. Okay, so if I see only two wheels, then probably I can say that that is a side view of the vehicle. Okay, so once I know that that's a side view of the vehicle, if I measure the top pattern, okay, I can identify which is the front side, which is the back side. Okay. Just to recap. So initially we detected the target, and then once we detect the target, we identify the target. Okay. So once we identify the target, we detected the target color. Okay. So based on the target color, we detected the orientation. Okay. All right. And this is with respect to the vehicles, not with the human. Okay. And when it comes to human-vehicle interaction, just as an example, so we are interested in all these kind of manipulations involving with the vehicle. Okay, like opening the trunk, closing the trunk, opening the hood, closing the hood, opening the front side door, closing the front side door, and so on. Okay. All right. So to detect these kind of vehicle interaction, so what we did is we did a CAD model for the vehicle. Okay, so we created a model. Okay, so we divided the vehicle into different zones. Okay, based on the views. Okay, so once we detect the orientation of the vehicle, we divide that particular vehicle image into different zones. Okay, for example, the side view might have like 20 zones, top view might have 16 zones, front and back might have 12 zones. Okay, so each zone is going to contribute to a particular location. Okay, if you look at this particular image, let's say that if if something is happening in zone number 15, okay, then I can say that somebody is manipulating with the hood of the vehicle. Okay, if something is happening in zone number 12, then we can conclude that somebody is manipulating the trunk of the vehicle. Okay, and if I see a person in zone number 16 and 10 over here, then we can conclude that the person is standing in front of the vehicle. Okay, so these are all the observations we can perform by dividing these zones. Okay, so we did almost 6 different views, and we developed different zones for all these views, so we can try to find out the whereabouts of the person with respect to the vehicle. Okay, so this is how we did. So once we have the zone identified, so now we can track the person. Okay, so once we track the person, we can try to identify the events related to that particular vehicle and that particular person. Okay, for example, you see here, this person opened the hood and is walking towards the back side of the vehicle. And over here, you see the person sitting next to the front tire and he's staying over there. Okay, probably is changing the tire or doing something or checking the air or doing something in the front tire. Okay, so we can come into different conclusions. Okay, all right. So based on the same approach, we can try to identify different postures of the person with respect to the vehicle. Okay, standing, walking, sitting on the car, crawling, sneaking, bending, and so many different postures we can try to identify. Okay. Okay. So before we do that, so okay, probably here. So this is how we do this. We try to identify all the events from each images, and then we generate those messages, okay, with respect to the zone, where the location, where it is happening, what is the timestamp, and all those details. Okay. So once we have this information, now we perform an pattern matching or ontology matching, okay, and then we generate a semantic messages. Okay. For example, this sequence of images we can summarize in 2-3 lines. We can say that the driver parked the vehicle in the parking lot, opened the hood, walked towards the trunk, opened the trunk, and walked towards the hood, and he was doing all those activities. Okay, so we can generate a simple messages summarizing what that person did. Okay, if the authorities are interested, if anyone is interested in a particular message, they have the timestamp. They can go to that particular image and see what is happening in that image. Okay, all right. So before we go to the next information, I just want to show a simple video. Okay. So this video, this is very simple. This is, for example, if one person is involving with the vehicle, how can we generate the message? Okay, so we can try to perform the zoning approach and then try to identify this person, tag the person, and track that person. So every time we can generate a message, simple message saying that the person left the hood open, or person walking towards the front vehicle, or front side of the vehicle or back side of the vehicle, and so on. Okay, so this we did with one man, with one vehicle, and in the daylight. Okay, so and we were interested that can we detect this in the nighttime. Okay, so what we did is we used the same scenario, but here we used a Kinect camera. And I don't know how many of you have used the Xbox 360 Kinect 1. So we just used the Kinect camera and placed that camera in the dark in the parking lot, okay, to where there is not much light. So using this Kinect camera, we can able to identify the activities of this person with respect to the vehicle. Okay, because Kinect has a depth map, okay, a depth camera, in the sense you can identify the depth information as well. Okay, so this was a little interesting for us. So instead of using an infrared camera in the nighttime, we can even use a kinetic camera to identify the actions. Okay, and another thing I want to show, for example, the reason why we use a kinetic camera is, let me show you this. Okay. So if you look at this, this is the optical camera and this is the kinetic camera. Okay, so the person is walking with, in this area with respect to the person. And if you look at this, we can try to identify who's standing in the front, who's standing in the back. Okay, so it gives the depth information. So we can use the kinetic camera to capture the information. Okay, so this is the optical images and this is the depth images. So we can use that to identify the relation between the humans and what kind of action the person is performing when there is an absence of light. All right. Okay. One another information, very important information, is the state transitions. Okay. For example, let's say I generate the messages. Okay. How do we find whether this is a normal behavior or is an abnormal behavior? Okay. There's a plenty of different ways we can do this, right? Space is very important. Where that action is performed, that is very important. How the action is performed, that is very important. And what is the duration of that action, that is also very important. Okay. Let's say in your college, if you see a student running in the stairs at morning 8 o'clock, okay, probably we can try to figure out that we can conclude that the student is running late for the class. Okay. Let's say the same student is running in very fast at night 8 o'clock. Okay, that's not normal. So why the student have to run at night 8 o'clock? Okay, in the same location, if the student is running at night 8 o'clock, then this changes the entire pattern. Okay, so that's why space time is very important. Okay, and if a person is running in the road compared to a person running inside the library, compared to the person running inside, let's say, an airport, everything varies. Okay, same action, different location, that has a different meaning. Okay, same action, same location, with a different time, that has a different meaning. Okay, so we calculated, we accounted those information, space, time, action, relationship also, to identify the normal and abnormal behavior. Okay, and also we took the state transitions into account. For example, what are all the different postures a person can perform? Okay, and after we identify all the different postures, let's say in one image I see a person standing, and in very next sequence I see the person is laying down. Okay, what does it mean? Okay, probably the person has fallen down. Okay, so what is the intensity over here? So we want to identify. Okay, person standing, and in the very next sequence the person is laying down, which means the person has fallen down. Now the intensity increases. Okay, a person laying down, and in the very next sequence you find the person laying down in a different area. Okay, what does it mean? Probably the person is crawling to a different location. Okay, so all these actions with respect to the time we want to analyze. Okay, so we did a simple survey giving two different images with two different postures and kinematics and so on, and we asked the surveyors to identify what is the intensity you observe. Okay, how much abnormality you have observed from this sequence. Okay, so we factored that into our messages, and based on that we found the abnormality involved in that scene. Okay. Okay. All right. This is a very simple application. What we did. So after we generate all these messages, so we tagged this information into each images. Okay. So now we can start querying that particular scene. Okay. For example, let's say that we want to identify where this activity have taken place, how many drivers involved, what types of human activities have taken place, what type of human vehicle interaction have taken place, and so on. Okay. Okay. So let's do this. Okay. To generate these messages, we need a certain format to generate the messages. Okay. If the format is not the same, it is going to be very difficult for us to fuse this information. Okay. So what we did is we came up with this transducer markup language, a TML format that was used by the army folks, the government people, long time back. Okay. So we used that format, transducer markup language. Okay. So it is not only going to give you the information about the activities, it is also going to give information about the sensors as well. Okay, it is going to have the metadata. Okay, so based on the metadata, the timestamp, the space, and the event, and for each event we have 6 different attributes. Okay, all this information we would generate as a message. Okay, so based on this messages, now we can try to query the system. Okay, so once we query the system, we can get our necessary answer. Okay, for example, if I say who are the drivers of this vehicle, for this particular scene, it's going to say that H1 is the driver of vehicle V1 at this particular time, and then it's going to say H3 is the driver of the vehicle for V2, and later at a different timestamp, it is saying H1 is a driver of vehicle V2 and H3 is a driver of vehicle V1. Okay, what does it mean? So now we can conclude that these two human H1 and H3, they changed the vehicle. Okay, if they changed the vehicle, that is kind of abnormal. Okay, depends upon the location. Okay, so this has happened in a parking lot. And these guys were interacting something, exchanging some objects or doing something, and then they changed the vehicle. Okay, so that is not a normal pattern. Okay, so we are interested in these kind of patterns, and that's how we try to observe from these images. Okay, at this point, if you have any questions, I would take it. If not, I can talk about a few more things. Does anyone have any questions? That's open for the discussion. Any questions?
So no questions.
Okay. Do we have some time, or can we continue? Okay, then we'll stop right over here.
Hello, sir. Good evening, sir.
Sure.
Okay. Hello. You can close the session, sir. Very thank you, sir. It was a very nice and then informative session. I will thank you on behalf of all VVCE family, sir.
Okay. Thank you so much.
Thank you, sir. Thank you.
Thank you. Thanks for having me. If you have any questions, you can ask me or you can email to me. Probably we can discuss later. Okay. Thank you so much.
Okay. Thank you.